Hi, my name is Rob and I'm building a hypercar. Today we're working on our CNC mill by adding the wiring and the end stops. Because the machine will move a lot, right? The whole gantry will move down the length of the table and up and down. There's obviously a lot of wiring that has to go through those different elements for the motors, for the spindle, and for the sensors. They all need to move. So we'll have some tracks running the length of the table and the height of the gantry to guide those wires so they don't get mangled. I will be mounting 2020 extrusions at different places on the table and on the gantry to make sure that I have something to connect the cables to. So let me drill some holes. This one is going to be attached to the table, so it needs two 6mm holes, 2 inches apart. So let's drill those. So because we have to go across the linear rail, I'm putting a spacer down. It's not the prettiest, but it will be sturdy and it will work. Let's see if I drilled the holes in the right spot. So pretty obvious why those holes are really handy, because it's really easy to mount things to the table. And of course this is on the work table, but the gantry only comes to here with the side. So we won't be able to cut from up to here, not any further. So this first part of the table is dead space, so we can easily mount parts there. I'll probably also mount my mounting hardware and everything else in that space. For those of you that paid really good attention during the last video, in a later video we're going to need these 2 mounts. You may have remembered that I put some clips on here while I was putting it together, just to make sure that I could attach these parts. So let's set those clips up to the right height, which is not that critical. So let's attach these. Last one, same trick. So now that we've got 3 mounting points, one that's stationary, stays with the table, one that moves on the x-axis, so it goes with the gantry, but just the length of the table, and one goes with the gantry and goes up and down. So we can connect from the one that's stable to the one that goes to the gantry, and from the one that goes to the gantry to the one that goes to the carriage. And because I didn't think you guys wanted to see me thread wire through cable guards, I prepared all that. So the wires are in the cable guard, not all of them, so we'll be threading some more later on, but they're all here, so let's start attaching. Yeah. So I decided to do the long one, the X one, on the outside and then work inwards. So first this one. And then this to the carriage. So let me make it somewhat straight. This one goes from the stationary, the table, to the carriage and goes all the way over. I'll print some 3D print some clips to attach them to the extrusions, but it goes all the way over to that side, because this one attaches to the Z motor on this side. As you may notice, I bought wire with the same color codes. It's special wire for stepper motors, so it's harder to make a mistake. So the other wire that goes from the table to the carriage is shorter, and that goes to the Z axis, right on this side of the table. So let me twist them and tie them together. So then there's another cable. It's a thinner cable. It's hard to see on video. It's even hard to feel. That's how close they are. This is for the sensors for the Z, and we'll use 2 pairs. So 2 pairs for one side and 2 pairs for the other side. Because for the end stops, we only need 2 wires. So this one is for this side, and then there's one for the other side that will be paired up with the signal wire. Obviously it's too short. Yes, I know I messed up. I cut it too short, but luckily we've got tools to connect wires back together, so we'll make that happen. Then, of course, from the gantry to the carriage, there's again 2 wires. There's a 4-strand wire for power that will go to the Y motor. So right here. So again, I'll tie them together so we can't do this wrong. And there's also a wire here with, again, 4 strands. We only need 2 of these, so I guess I'm going to be pulling this one out and using 2 of the wires for the other side of the Z side. So I'm going to be mounting the motors to the wiring harness. I'll hard mount those. For that, I'll be using these solder fittings that are crimp fit. I know some people really don't like these, but they work for me, and they seem to be working really well in high frequency situations or medium frequency situations like what we have going on here. I'll be packing all of that in some shrink wrap. This is 4-to-1 shrink wrap with glue, so it will be fairly tight. So let's get going. We've got a lot of wires to do. Let's slide some shrink wrap on the table and the cable. Slide that far enough away so it doesn't get in the way of your heater. So you have to make sure you stick the strip part through the solder end. Same on the other side. And then hold the whole thing in front of the hot air gun and it will connect. Doing this, the cable does get hot, so watch your fingers. So now that we get to the fourth, the cable is actually getting pretty warm. So my fingers are not enjoying this all that much. But there we go. 4 wires connected. Now let's let it cool down just a little bit. So when we slide the shrink wrap over, it doesn't immediately attack to it because it's shrink wrap with glue and it will glue itself down pretty quick. There we want a little bit over the black cable, so somewhat looks nice. So let's shrink it. So the wiring is all connected and safe. The wires coming from the controller to the motors are now one. So let's tidy it all up. Mentioned earlier that these control wires for the end stops are actually in the wrong way. So I'm going to pull it out for a bit and then let's see what we can do. So that's out. It needs to go back in, at least half of it. So we'll do that in a minute. So I'll split them now. Then I can use the blue-green for the end stops on the other Z sides. The next part, well, that's right here. 3D printed some blocks and got some mini switches for end stops. So these are for the X-axis, so let's start installing those. I printed these to fit snug against the linear rail and attach the 2 of the holes in the table and have a sliding fit. So I can adjust what spacing I want. And by doing that on the left and the right side, I can make sure that the left and the right stay perfectly aligned. So this is one of those situations where that matrix of holes really pays off. Makes it really easy to mount things to the table in a very uniform way. Well, very sturdy, and switch has perfect alignment, so the linear rail will run right up against it. I think it's about here. For now this is okay, but let's do the other side. Now before we install this one on this end of the table, let's put the wiring on, because this one is actually a little harder to take back off. So I'll get the wiring attached to the right switches. The stop system here is going to be a normally closed system, so I can have one circuit, 2 wires with 2 switches on it, and the computer will know when it's moving this way and the switch goes, it's probably the minimum X switch, and when it goes that direction and the switch trips, that it's the maximum X direction. So let's get some wiring prepared. If you paid attention earlier, you noticed when I put the cable control part in here that I put this piece of scrap 2020 in between. Well, there was a reason for that. It's actually where we're going to be mounting the limit switch right in that same spot using the same fasteners. And because we're mounting this on a metal conductive table, I'm putting a little bit of electrical tape in between there. It's just a 5-volt ground signal that goes through here, so not all that much, but just a little bit of added protection to make sure we don't get any shorts. When I slide that into place where it will bolt on, it is actually against the end stop. It's past where it's going to go. The carriage is now all the way to the back, to the end stop, and I want it just a little bit further to have a little bit of space, and the switch will make sure that that happens. So that's the left side for the viewer. X-axis limit switch is done, both the minimum and the maximum limit switch. The same is going to happen on that side, but it's all over the same. Don't want to make the video unnecessarily long, so I think you'll believe that the wiring is the same. Let's skip to the Z-axis. For the Z-axis, I 3D printed another mount. Very simple, just a 4mm flat piece with the same bolt holes that fit the switches, and again a sliding fit set of holes that fit some bolts and nuts to mount to the 2020 extrusion. We'll be using that same mount system, so got several more printed up, both on the minimum and the maximum of the Z-axis. So let's put this one together. I'll show you what it is and where it will be mounted. So I'm not entirely happy with how the Z-axis mounts are fitting. I only fitted this side so far, and yeah, don't think they're quite right. But in order to test them, I need to be able to cycle the system. So let me put together some test electronics so I can cycle the system and see what's going on. So I connected both Z1 axis and Z2 axis to the temporary controllers, computer, the power supply. I'll put the power supply up there. Kids, don't do this at home. For a test rig, this is fine. This is not fine for production. So I know what I'm doing this safe, but that ain't safe. So let's power up the computer. It's just USB and the power supply for the steppers. You can see everything comes on, and I've got a little switch to make it turn. So let's see what direction it goes. Doesn't move quite as stable as I wanted to, but we haven't aligned anything yet, so that makes sense. So let's see what happens to the top switch if we run it all the way up there and see if it trips it. Well, obviously that misses, so back to the drawing board. So let's test the lower Z-axis switch as well. So take it all the way down. Obviously the alignment hasn't been done yet, so it's not running quite right. We'll do that when the table is in its final spot and we can put everything level. The switch is in a totally wrong place, so let's move it and see if that works. I'd want to mount that there somewhere. Obviously that's not going to work, so I have to move it up a little bit so the 2020 extrusion, grab it, which is a great place, but then I would have to put the switch on the other side of the plate. So let me turn that around. Well, I flipped the switch around from the left to the right side of the plate. So let's see if that fits on the extrusion. Well, I think I found a good spot for the top Z-axis. I guess I said that before, but if I mount it against this plate, I can take the 2020 extrusion here and pick that up. And that's a nice solid spot. Obviously, I didn't prepare for that. When I printed that block, I didn't make any provisions to mount this, but I think it will be sturdy enough if I drill some holes and put some screws in it. So let's try that. So having the limit switches in allows us to measure what the actual travel distance is. It's from the switch there to the switch there. So let's measure that. So let's trip that switch, hold it there, trip that switch. That's about 640 millimeters. That is more than the 610 millimeters that we designed it for. I'm very happy with that. Let's also measure the distance between the limit switches on the x-axis. So that one is right against the limit. So then on this side, we're at about 1570 millimeters. Our goal was 1210 millimeters, so this is way beyond our goal. This will work very well for us. So now that the X and Z limit switches, at least on one side, have been installed, we can actually start trying to do some stuff. So next is the Y switches, but we'll finish that when the rest of the wiring is done. By the way, the speed may change if we put a bigger controller on. Right now it's just a simple Arduino that I had laying around. With a faster controller, we'll be able to send faster signals and change the speed of the carriage. Now you may wonder why we have limit switches on both sides of the X and both sides of the Z. Well, you may remember there's two motors on the X, two motors on the Z, and while they should move in parallel, you know there's always going to be some differences. By having limit switches on both sides and controlling the motors independently, this machine will be able to square itself up. So left and right will be always against the limit switches at the same time, and that by making sure that it's perfectly squared off every time we zero the machine out. Another part of the wiring, obviously, that we have to mount the offside Z wiring, so the other side from where the wiring loom is, to the gantry to go across it. So we have a cable for the motor and a cable for the sensors on this side. I've got a couple of clips. Obviously I 3D printed those. These are just downloaded from the internet, didn't design those. They're excellent. They clip into the 2020 and really tighten the cable down. So the cables are a bit too long. Let's pull it tight. So I finished most of the wiring off camera because, you know, how interesting is pulling yet another cable and connecting yet another cable. But there's a couple of things I want to tell you about. So all the cables are now within the cable guard, except for the 220 volt, that's for the spindle feed. And why is that not in there? Well, you may say because I got the cable guards too small. Well, actually it's a different reason. Because that's AC and everything else is kind of different frequencies. I don't want this to wrap around the cables that control the motors or the sensors. So I zip that, tied that to the outside of the cable guard, so we don't get any magnetic interference, or at least a lot less. This is one of the cables for the motors, in this case the offside X-axis. And you can see there's quite a few cables on here. We have 4 for the motor, because there's 2 windings with positive and negative. Then there's 2 for the switches, and there's 1 that's just a loop. And you wonder, well, why is there a loop? That doesn't do anything. Well, actually, that one is really important. That one is for safety. It is wired to the larger loop that is for the emergency stop. And what this does, if any of the motors are unplugged, the system will go into emergency shutdown and stop all operations. So if someone or something pulls on a cable and unplugs it, it automatically stops the full machine. So that's why that little loop is very important. Now every axis, you may remember, has two switches, a minimum and a max switch, but I only have 2 wires. Well, how did I do that? I make a loop out of everything. So it's a normally closed system. So it's a continuous loop, and when it gets interrupted, when one of the switches gets touched, it interrupts the loop. And those 2 switches, because the computer will know, is the carriage moving this way or that way, so it's hitting the minimum stop or the maximum stop, it will know what that interruption means. So let me show you how that works. So to demonstrate that concept, I wired this light, and it's really bright in my face, so hopefully you can still see something, into the switches for this side of the x-axis. So it is now in the loop of the switches. And what you'll see is what happens if I toggle this switch, the minimum switch for the x-axis, the light will go off. And if the carriage moves away again, it comes back on. Same on the other side. So if I move over to this side, same here. If I toggle that switch, the light comes off. So the circuit is normally connected, normally closed as it's called. So the computer will know no switch is tripped. And as soon as either the min or the max switch is tripped, the signal is interrupted, and that means that there's something going on with the switches. And all axes are wired that way, and that way I only need 2 wires to run every axis. So that same idea of that continuous loop that gets interrupted if there's something going on is used for the emergency stop system. So that loop on the plugs, there's one on every motor, so if it gets unplugged, it interrupts the signal, but that's also on the emergency stop button that will just be sitting on the table somewhere. So as soon as someone hits it or something hits it, that will interrupt the signal and stop the system. So in this video, we wired up all the motors, wired up the end switches, put the plugs on, wired up the 220 for the spindle motor, and make sure that all the end switches are in the right spots and ready to go. So that concludes the video on wiring for our CNC mill. If there's anything specific you want to know, comment, and I'll try to respond to you as fast as possible with the information you need. Also, please subscribe, like, tell your friends, and if you haven't seen it yet, make sure you watch our shorts, because in the making of this video, we got to add an extra badge to our board of shame.